Hi, it's Tim from Maritide Industries again. So today what we're going to tackle is we're going to tackle how to lay out spindles, posts, pickets, whatever have you. And as you can see here, I'm putting new railings on this deck, and one of the aspects to it is spacing spindles, and so that can be done for safety or aesthetic reasons, but usually there's a number which you're trying to hit. So anyways, as you can see, my work platform is a ladder. Those are my feet. And what we got is we got the last little bit up here, and as you can see, I've already laid out some marks here. Got the marks, and the question is how do us professionals get this perfect spacing? So I'm going to try and take you through it as quick as I can, but there's a little math involved, and I've jotted it down. So what you need to do is you need to start by measuring your total distance, and that's from an inside measurement, and that's from inside to inside 2 points, right? Now, what you do is you take that measurement, and we're going to look. In this case, my measurement is 25 1/4 inches. And what we do is we add what we call a ghost spindle in this case. And the ghost spindle dimension is 1.5 inches. And as you can see, these are my spindles. They're 2x2s, so their actual measurement is 1.5 inches by 1.5 inches. You add those two measurements together, and you come to 26 3/4 inches, which in decimal form is 26.75. You take this number, and this is your working number, and you divide it by the desired space plus spindle. So in this case, I desire to have a space of roughly 1.5 inches, and I know that my spindle is 1.5 inches. If those two are added together, I'm left with 3 inches. So I divide this working number by that number. As you can see here, I have 26.75 decimal format for 3/4 divided by 3 equals 8.9166. Now this number gives me some information. It tells me that it doesn't divide equally and I need to do something. So in this case, it's really close to 9. So I'm going to round it up and I'm going to redo it. So again, take my working number, divide it by 9, and it leaves me with 2.972 inches. Now we have that age-old problem where we have inches in decimal format and our tape measure is in sixteenths, and we need to get it from one to the other. So what we do in this case is we subtract our 2 inches, and that leaves us with just a decimal place. Then we multiply it by the number of eighths or sixteenths or 30-seconds we would want. And in this case, I want sixteenths. So I multiply that by 16, and that gives me 15.555 sixteenths. So you take the sixteenths, you add it to your inches, and that would give you 2, and I'll add that right now, 2 and 15.555 sixteenths. Looking through the lens. Now, that becomes the spacing. So I've come out here with a tape measure, and I have laid out 2.55 or 2 and 15.55 sixteenths repetitively across here. Now, that's great. The thing to note with this formula is that gives you the spacing is the spindle. That's the total of a space and spindle. So the spindle goes here. It is a layout that is back. So you measure from, and back is where the spindle goes. From the last spindle, away, and back is where the spindle goes. All right. So the way I do it in practicality is that to get that spacing, especially in a case like this where I can't actually put a spindle in and put a level against the spindle or some sort of plumbing device to get everything true, I just make a spacer block. And how I make the spacer block is I take this working number, go to my chop saw, butt a piece of scrap up against my spindle, measure from the spindle to the scrap, make a mark at 2 and 15.55 sixteenths. Make a mark, cut it there. Now I have that 2 and 15.55 total spacing combined. So that's how you do it. And there's really nothing else to it. And for those that just want the information, you can stop watching now. If you want to kind of explore why we have to do this or why it makes sense, we can look at this diagram. So it's kind of perplexing for some people as to why you have to add the ghost spindle and the math that's involved. And here we have a hypothetical situation. And I've got a hypothetical situation where I have 3 units and I want to divide this space from here to here by 3, represented by these 3 x's. And I want to do it, I want to have spindles in here. And say the spindles were just like the spindles I'm using, and they're 1.5 inches wide. So I could easily divide this space by 3 and end up with units of 1. So all these x's would be 1. And I would have a total of 3. And then when I came to put my spindles in, say that represented the center mark, well, the spindles are 1.5 inches total, so that means that 3/4 of an inch are projecting out from each side of these center marks. Well, the problem is now is that the distance in between this unit here is 1x minus 2 times y. If a spindle was divided into 2 and given a y format, it would be 2 times y. And that works. So now we had even divisions, but now we've added material, and it has made the space in the middle smaller than the ends, because the end spacing is from here to x minus 1y, and in the middle it is x minus 2y's, and over here it is x minus just 1y again. So by adding the ghost spindle, we accommodate for this problem. And the way is that if you take the original problem and you divided by 3, then you plunked in your spindles, and this space is smaller than these 2 spaces. To fix it, if you were in the field, you could correct it by just moving in these ends by the 3/4 of an inch. And that would fix it. So by adding the ghost spindle, we've essentially done that. Mathematically, we've added the 3/4 so that we can just move it in. Anyway, I hope that helps you on your next project where you have spacing, whether it be fence posts, railing posts, railings, pickets, anything, stairs even, anything. Works good. Somebody else taught me, and I'm passing along. And if you have any questions, comments, leave them or ask them. Till next time, it's Tim with Airtight Industries.